Merhaba Mert. Sanıyorum bir tek sen varsın. Merhabamış. Evet. So, good afternoon, ladies and gentlemen. Can you hear me? Okay. Good. Thank you. So, merhaba arkadaşlar. Today, sorry for a little bit late. We said we were agree on that we will start the lessons at 1 o'clock. Was correct, isn't it? So we decided in our last lessons. So I'm a little bit late. Sorry for that. And now we will start. We already started to discuss the theory of machines, and we now I'm trying to share with you the slides, and then okay, where's the slides here? So okay, the uygulama ekranı, okay, here the file to make ekran, okay, here. So then we are here. I'm sharing the screen with you now. So and then going to the lesson. Okay, and here 18. So then, okay. Oh, not this one. Sorry, not this one. So we were somewhere here. I will show you now. So maybe a short summary what we did. We talked about what is the topic, which topic we are going to discuss, like kinematic and kinetostatic. This is the topic on the dynamic, we said, and the machine and mechanism. So we talked what is machine, what is mechanism, and then so how can we design, what is the design process, and what are the performance specifications and so on, and the creative process. To design a machine, what is the creativity, and what type of process is it, and so on, and how can we evaluate our design. That means to evaluate according to the weighting factors and so on. And then we talked about what is mechanism, what is rigid body, kinematic, kinetic pair, and kinematic chain and mechanism. And machine, we talked and said what is machine, machine and mechanism, we all discussed. So and then we said, what is that? This is a machine, we said, according to our definitions. And then we started to talk about the certain definitions like kinematic, link, rigid body, and joints, and pin joints, or revolute joints, and then slider joints, or the slider or prismatic joint, and then higher order joint like gear, for example, and we said cam. So cam mechanism we will talk later. It is a separate, it's a topic by itself. So then we talked what is the links and simple links, and then the complex links and so on. Now we were on this page, huh? So now today we will start to talk about the mechanism and the model of kinematic model of the mechanism, and later on kinematic chain. and then we are able to describe what is going on in these lessons and what we are going to learn exactly. So you see here there is the mechanism used here, like the mechanism where all parts are connected to form a closed chain. So this is the linkage. So here we have an example, identify the number of links. So there is a mechanism you see. Let's use the laser pointer. You see there's a mechanism here. So then with this mechanism there's the door, like a small door, we can open and close using this mechanism here. Or let's say we can, if I use the column here, so here maybe move it up and down here, so that direction or in that direction. So then here we have the door moves also here up and down, and for that we have a mechanism here. So mechanism. So how does it work? Actually, if we look at this picture, it is not clear seeable what's going on there. So we have to come from the mechanism to the kinematic model. So actually, door open the dump truck tailgate. So this is identify the number of links and the type of the joints contained in the grain door of the dump truck tailgate. So let's think about how can we identify it. So the mechanism, how can we identify it? So for that, I am going to use another color. So we see there is a slider here. There is a slider like this. So there is a slider. So the slider is supported from the both sides, left and right. So like this. Okay. And there is a pin joint here. You see here. And there's a bar like this. And there is also a pin joint here somewhere. And another bar. Which is fixed here somewhere. So that means it seems like this. So you can easily imagine if I apply, let's use another color. If I apply the force here to this arm, like this, F in that direction or in another direction, like F. So what will happen now? So it will happen following. This part here will make a rotary motion like this. Circular motion, let's say. The circular motion will move on this circle with this radius here, so, and radius R, let's say, and this link between the slider here, the link provides the linear motion for the slider. So slider will move up and down like this. And we can open the door and close the door. So our main issue in these lessons will be that how can we come from such a picture which shows the reality, the real picture. How can we pick out the mechanism used here? So This will be our topic for today. Now, you see here the the kinematic model rear window wiper mechanism. This is a rear window wiper mechanism. You can imagine from the car. Each car has such a wiper, window wiper. Not only the rear, also in front of the car. But you see, this is a mechanism. So, but this show the real picture. I mean, which we have in the car. So from this picture, we have to drive the real mechanism. So this is the important issue. How can we come from this real picture to the mechanism? How can we identify the mechanism used in this picture? So we have here, you see, the one arm here. This is, let's use the another color, like red one. Okay. So this part is here. You see, red one is this one, AB. This is here, A and B. Here, A and B. Okay. Then the part BC. So the BC is like this one here. So this is BC. Okay. BC. You see, in real picture, these elements could be shaped different. So not like a bar. And then we have here D, which is fixed here. This is here fixed. Let's use another. So another. Oh, good. Use another picture. Another color like this. Okay. So this is a fixed joint here. That means ground. And this is also fixed here. But so let's use it here. Okay, this is also fixed here. Okay, like this. And then we can build our mechanism. Let's select the color red one. So this is the link. And this is also the other part of the link. Like this. And you see, this is a complex member. So, okay. So this is a complex member like this. And if we can apply it, so it moves, let's say, up and down like this. But we derive from here, huh? So if you derive from here, let's say it derive, this is the crank at the part of crank. So we drive in that direction. This is clockwise. So then if this part AB moves in that direction and BC and goes in that direction, and since it is fixed here in that point, here it is fixed in that point. So it moves in that direction. So this is the mechanism we have here, you see. This is a, say, the solid member. Solid member. And if you drive the machine from here, from the part 2, crank, so then the crank makes the rotary motion, circular motion, the point B. Each point actually on the AB execute the rotary motion for the circular motion. So, but not BC. BC is executing the general plane motion. And this also executes a rotary motion. There's also here the rotary motion here. And the BC, the motion of the BC is the general plane motion and consists of linear and rotary motion. But the part 4 make a rotary motion. So, and this point C is moving on that circle with the center of D. So the mechanism from this picture has to be analyzed. So first of all, what we want to do, so what are the fixed points? What are the fixed points? So you see here there's a fixed point A and D. There are 2 fixed points, and B, C, X are not fixed, movable. They are moving. And what we want to do, first of all, we have to check how many members mechanism has link. So we have here, let's say the member 1. So the first I have to make clear. So the number 1 we give for the fixed part. The A and D, we don't see that, but actually we can draw this like this, A and B like this. So with this color, this is also a link, a member, but this is fixed, you know, doesn't move. This part doesn't move. So therefore, we give the number 1 for that. AB, the number 1. Sorry, AD. And AB, number 2, we give the number 2 for the link AB. And BC, we give number 3. And CD, of course, is expanded in that direction, CX direction. We gave the number 4. So that means we have such a mechanism. Here, maybe there is one more. So, and this is the fixed part here. And we have here the member. This we call member 1. And we have here also the other member, which is not seeable. And this is this one. This we call also 1. That means this member is 1. This link is 1. So, and then we said this is A, and this is B, and then there are another one here, and this is, we have also a link here, So this is 1, and this is 2, and this is 3, and this is 4. Huh? This is 4. And this, the member 4 is shaped like a triangle. So because of the car wiper. So, but this is one member. The shape could be, somehow different. This is one solid, one member. So we have a mechanism consists of 4 bar. That means here the bar 1 and 2 and 3 and 4. This is a 4 bar mechanism. So this is a 4 bar mechanism. Nice. Consists of 4 bar, and all of the joints are revolute joints, as you see here. Huh? Revolute joint, like we said here. So pin or primary or revolute joint. Huh? So like this, revolute joint, pin joint or revolute joint. Okay. So the beginning of the mechanism is very important, because if you understand from the beginning, so it will be easy to you later for you to analyze the mechanism, because we will later on to discuss the calculation of the position, calculation or drawing of the position, or calculation, velocity and acceleration, and later on, if we have time, forces, all those things on this mechanism. And therefore, we should be able to analyze the mechanism from the picture and get clear understanding of that. Okay, then another mechanism. So draw the kinematic model or kinematic model of this mechanism. This is a shear press. Huh? This is a shear press. So let's try to solve it. Huh? What type of mechanism we have here in this shear press? Actually, you can easily understand how does it work, huh? It is not so complicated. So how many links have this mechanism? I cannot see what you write. Maybe you can talk, huh? Then I can hear your voice, because I'm sharing the screen and I don't see the audio platform and the messages. So, okay. This is the part 1. Fixed, doesn't move, isn't it? 1. And this also not move, huh? This is also part 1. And this is part 2. Here we have a revolute joint, and here we have also a revolute joint. And this is part 3 of this mechanism. And we have once more, which is also moving. And this is the part 4. Cut the object here. the cutting part, H. So that means we have a mechanism consists of 4 bar. We can say 4 bar. And how can we draw the mechanism? I'm the kinematic model. We can do following. So this joint is fixed. Like here, we have a joint, pin joint, fixed. So this is fixed. And we have here slider somewhere, huh? Like this. This is our slider. And execute the slider motion like this. Linear motion, huh? Linear motion. And we have here one joint. And this joint is connected to this one. But this is a whole, see, this is a solid part. That means the motion occurs between this part and this part, okay? So let's give the number. The number here is fixed part, fixed. Member we call always 1, or we give the number 1 for the fixed part, fixed member. This is 1 here. This is also 1. And let's say this is 2, and this is 3, and this is 4. So 4 bar mechanism consists of 4 link. And we have also 1, 2, 3, and 4 joint. Here we have a pin joint, and also here pin joint and pin joint, revolute joint, pin, revolute, 3 revolute, pin joint. And here we have slider. Here the joint between 4 and 1 is slider. That means prismatic, like we learned here. So this is slider, also prismatic we call it, slider motion. So, and in machines, if we design a machine or develop the machine, we have such a connections everywhere to prismatic joint or revolute joint and gear joint and so on. Huh? So therefore, we start to learn it. So, okay, this is the mechanism. So this is a simple part to analyze the picture and draw the kinematic model. And you see here, this is the same. Huh? So we have here the part, okay, it's part 1 and part 1 and part 2 and part, this is maybe 3 and this is 4. It doesn't matter which number you give which one. But this is also, we have also the same mechanism here. Okay. So kinematic diagram of shear press seems like this. Let's have another example, like vice grip. So you know that, huh? So try to draw the kinematic diagram of these mechanisms. So actually, this member is mostly fixed. So during the operation, when we use this vice grip, this part will be fixed or doesn't move. We move actually this part, so up and down, and we do what we want. So, and therefore we can assume that this is a fixed part, and in this fixed part we have here the one joint, pin joint, as you see here, one pin joint here, and here also another pin joint we have. And here we have pin joint, and we have here also pin joint. There is no slider joint here. So then we can say, okay, here we have our fixed part, and this is the link. Let's say this one here. This will be one. This is one here. This is one. And this should be two. Let's say this is two here. Also two. And we have another one like this. And this is also a solid part. The joint is between these two and let's say this is three. Okay. And we have also here one fixed part. This is this part, this joint here, and we can connect them. And which moves like this, so make such a motion. This is one part here. Okay. And if I operate from here, that means if I operate here, this is, let's say, X. So I can move like this, up and down. And what will happen? If I push down, this goes in that direction, and this goes in that direction. And if you have here a fixed part, so you can easily imagine. So we clamp something here, we can clamp. So this is same part, so like this, same part. So this is also 1, 2, 3, and this is 4 here. Eh? This is the link 4. Okay. This is also a 4-bar mechanism, consists of 4 members, 4-bar mechanism. And we have also a picture here. You can see this is 1, 2, 3, 4. So I was like this, and this is also not a, let's say the different picture. So seems like that. 1, 2, 3, 4. So we can say this is 1. Okay, this is say 2 is this one, and 3 is this one, and 4 is this one. Okay, it could be. I mean, you can give different number for different members. This is not a big problem, but it's a 4-bar mechanism, A, B, C, D, and we can also say this is the A, B, and C, and D, like this, A, B, C, D. So, like A, B, C, D. Okay. So we have another example. So on this example, we are going to again to build the mechanism used in this machine, or in this mechanism use kinematic diagram. We have to draw. So let's check it. Which part is fixed? This is fixed, isn't it? So this is the part 1. The fixed part is 1. Fixed part is 1. Okay. Then this part is we apply the motion here. The force may be like this. Force here, F, and then what will happen? If we apply the force, so it starts to turn around this fixed joint. This is fixed joint here. And then, because of the geometry of this member link, so this joint is also, this is not fixed, connected to this one, and is connected to the fixed one here, and is also connected to this one. And here we have a slider. That means prismatic joint we have here. We have here revolute joint, revolute joint, revolute joint, and here prismatic joint. And we use it, let's say, to reshape this part here. It's a small, like a small press, hand press. Okay, let's check how many members we have, link we have. So the link, first the 1, and then let's say 2 is this one, 2, and this is 3, and this is 4, and this is 5, and this is 6. So now we have a mechanism consists of 6 bars, or 6 members. 6 members. So there is not always 4-bar mechanism. There are also mechanism consists of more than 4 bars. So therefore, we will check some of them. There are lots of variants. I mean, different type of mechanism. Even if you have 4-bar mechanism, even if you have 6-bar mechanism, many different designs are possible. So then let's draw the mechanism from here. So we can say here we have a slider. This is slider. Oh, this is the fixed part. We say fixed part. Slider, and there is a revolute joint, and we have here the member or link like this, and we have here a joint consists of, or joint which we connect 1, 2, 3 members, and these 4. This is let's say this is 6 here. This is the 6 member 6. Okay, and this is, let's say, the 5, and we have here this must be also fixed here. So this is 4, and we have another one like this here. And here we have a joint, revolute joint, and we have, and here we have another one, and which is also fixed here. Which we call 1. The parts is fixed 1. Always we give the number 1. Okay. And then, of course, it has such a shape here. This is one part, one solid. So, and this is the part, let's say X, we apply the motion here. So if we apply the motion like this, so in that direction, so you can imagine it starts to turn here, make a circular motion, and then it turns also this joint, execute also the circular motion, and this part make a linear motion like up and down here, linear motion. So this is the coupler in between. Make this part and this part. Those are the 5 part 5. So we fulfill the number of the elements. 1 of the 4. I say 5, 4, and this is 3. Okay, 3, and this is 2. Okay, 2, and this is 6. Okay, here, 6. Okay, 1, 2, 3, 4, 5, 6 elements. So if I apply the motion here, so in that direction, so this, and since it has to be turned around this point, this is the center of the motion, and then this point, let's say we gave the we can define the joints. Let's say this is the A, and this is B, point B, C, and D, and it could be D and E, and so on. Okay, this is a 6-bar mechanism. Consists of 6 member 6 link. So do you have any question? Okay, not good. So then let's continue. So still we are busy with drawing the kinematic diagrams coming from mechanical shape, the picture of the mechanism used in the machine. So then you see it seems like this, eh? So it is also not different. Ours is also, I mean, it's also same. Eh? So, okay. So another picture. So this is a toggle clamp, you know, from our daily life. If we apply the force here like this, so we can clamp something here. Let's say there's a surface here somewhere, and we have a object here, and we can fix it like this. Eh? So this is also a mechanism, and we have to analyze the mechanism. So these are the kinematic diagram. So what is the kinematic diagram? If you say kinematic diagram, so we have to show the links and the joints. So, okay, this is the fixed part. You can imagine this is a fixed part, so we can say this is the one fixed part. And we have here 4 revolute joint. One is this one, and the other one is here, and the other one is here. So this is one, and this is fixed. And we have another link, and another link here, and another link. Okay. So this is the link here. Let's say this is 1, and let's say this is 2. 2 is this one here, 2, and this is 3, and 3 is this one here, is total, and the 4 is this one. It's the 4 one. Okay, then it seems like this. We have a mechanism, so we have here the fixed joint, and here also fixed second joint, and here we have link. We have another link here like this, and this is already, let's say, connected with this one, and this is also connected here. This one is connected with this one. Huh? So if I apply the force from here, you can imagine, so it moves in that direction, make rotary motion. This also make rotary motion. Since it is coupled or connected or the same body with them, and it will apply the motion in that direction. Okay, this was another mechanism, toggle clamp, and we use the toggle clamp and we create the kinematics diagram. So another one, so you see here also the same, huh? So we have the same. Yani, of course we can same kinematic diagram, not a difference. There's no difference between. So another kinematic model. So draw the kinematic diagrams. We have such a trolley, for example, car. So what is the kinematic diagram here? Because we have a mechanism to move the part here, the part of the car. So it moves like up and down, huh? So like this. And therefore we need a mechanism. So you see, there are two fixed points. One of them is this one, and the other one is this one. Let's have a here like this, two fixed points. Those are fixed points, okay? Good. And this we call 1. This remember 1. Okay, then we have a slider here, huh? Sliding. Also connected here. It seems like this, huh? So, of course, it's a hydraulic cylinder. If you apply the, let's say, linear motion, this is linear actuator in that direction, so then it starts to turn in that direction. If I make return stroke, and then it goes in that direction. This is also 1, let's say 2, and 3, and 4. So like this, huh? Of course, this part is could be shaped differently. I mean, this part could be shaped differently because we use it for the car and to transport. I mean, the goods. This is the container. So, okay. So we finished this part. Do you have any question?
I have not question. Thank you, teacher.
You have a question?
No.
So, which?
Thank you.
No. No. Okay. Good. Then let's make a 10 minutes break, huh? Then we will start 15 at 15, 3:50, 2:15 we will start again, okay?
Okay.
So we can start now, huh? Okay. So this is the second part of our lessons, or let's say maybe second chapter. So can you hear me?
Yes, teacher.
Okay, thank you. Thank you. Okay, let's continue. So I already mentioned at the beginning of our lesson that we mainly deal with geometry. Geometry is very important in these lessons. We will draw and we will calculate, we will use trigonometry, and so on. So since we will deal with geometry, we need compass, we need a protractor and ruler. So you need it also in exams and in lessons, because in exams you will get some question related to the drawing and calculating. And also you need a calculator. Okay, so you may remember we said we have different type of. So we had I said we already discussed some mechanisms like 4-bar mechanism. So like 4-bar mechanism, like we have here the fixed part, let's say fixed part, and so like okay, fixed part. We number it with one, and here maybe another member 2, and another member here, and here we have another member connected to this one, and this we call 3 member 3, and this is 4. So therefore we call 4-bar mechanism, consists of 4-bar. And the joints are very important. Here we said revolute joint or pin joint, but mainly used revolute joint, revolute. In some cases, we have also a slider or prismatic joint. Okay, so the member or the links we use between, so could be binary like this one here. This is a binary. This is a binary one. Okay, could be binary or ternary. That means it has like another, like this shape, another joint here, and with the joint maybe connected to another links like this. Could be, I mean, so in that way, So, and this is ternary. This we call ternary, and this is binary here. This one. So this we call binary. Binary, and this is ternary. So ternary. Okay. So in some cases we have such a link element. So ternary, it has 3 connections, 3 pin connections, 3 nodes. And the quaternary had 4, has 4 connections. So if you have a mechanism somewhere, or if you phase, so then you shouldn't forget it. Binary link, ternary link, and quaternary link. Binary link had 2 connections, ternary link had 3 connections, and quaternary link had 4 connections. Okay, now let's come to the interesting part of these lessons, degree of freedom. Degree of freedom. So, what do you think? How many degree of freedom has an object in space? So let's think about an object in space. How many degree of freedom has? So generally, if we use here any object, let's have an object like this one. So it can move in x direction, isn't it? In x direction. And it can also rotate around the x direction to freedom. So it can move in y direction, means it can move in x direction and move in y direction. Of course, in negative or positive direction is possible. So it can turn around the y-axis. So additional 2 degree of freedom. Here we have 2 degree of freedom. Here we have 2 degree of freedom. And in z direction, again, can move in negative or positive direction, linear motion, that means, or can turn, rotary motion. So we have also here 2 degree of freedom. That means any object in space have 6 degree of freedom. And 3 of them is rotary motion, rotation, and 3 of them is the linear motion. That means translation. 3 rotation and 3 translation. And you see it here. In x direction, left and right, and also the rotation around the x-axis, and in y direction, left and right, rotary motion, which is a translation, and rotation around the y-axis, and also in z direction, a translation left and right, or up and down, let's say, for the z-axis, and the rotation around the z-axis. So that means generally we have, so any object has 3 degree of freedom in space. But in machine, we don't allow that all members can move in any direction. If all the members in the machines consist of machines, so start to move in any direction, you cannot do the work. So we have to restrict some of them. And we define the degree of freedom. Therefore, in revolute joint, we have only 1 degree of freedom. Revolute joint, you see here. This is only rotation. So we have on the rotation here. So let's have another color. This one. We have only rotation like this in a revolute joint. Of course, could be left and right, doesn't matter. So around the axis here. So if we have revolute joint, the 1 degree of freedom. If we have a prismatic joint like this, so it can move left and right here. Prismatic joint. This is translation. This is rotation. No. So if we have a helical joint, this is also 1 degree of freedom. This is rotation. Whether if we fix the screw, we have only the linear motion. So if we fix the nut, so we have rotary motion. In case we have cylindric joint, you see there are different type of joints. So and between the members in the machines, there are joints and could be different type of joints. But mainly we use the revolute joint and the prismatic joint. Sometimes also the helical joint. And in some cases, you use a cylindrical. I mean, the motion is possible. That means the cylindric joint has 3 degrees of freedom. One of them is the translation like this, translation, and the other one is the rotation around this axis, left and right. So, rotation. So, from 1 degree of freedom, it goes in the 2 degree of freedom. There are joints which provides 2 degree of freedoms. But if we come to this joint, I mean the spherical joint, we have 3 degree of freedom. 3 degree of freedom. It's interesting. You know, the people, it's very interesting. They work a lot about it to system for the systematical, I mean, analysis of the motion analysis within the machines, which type of motion we need, and how can we create this motion, and which type of joint we can use, and so on. And here you see there is a spherical joint, and spherical joint has 3 degrees of freedom. There is no translation, only rotation. That means this joint can execute the motion, the rotary motion around the x-axis, y-axis, and z-axis. Therefore, we have 3 degrees of freedom, and all of them are rotation. So if we have a plane joint, this is a plane joint, we have also 3 degrees of freedom. Can move in x direction and y direction, and can turn around z direction, like this one. So the rotation around these axes, and the linear motion around along x and along y-axis. And this is the z-axis. Translation along x and y-axis, rotation around z-axis. So 3 degrees of freedom. Okay, this you shouldn't forget it. This is you should not forget, and it's very important. Any object in space, let's say in space, sky have 6 degrees of freedom, and if we design a machine or any parts of the machine, of course we will have some motion, because without motion work cannot be done. And since we have the motion, so we have to define degree of freedom in joints. So which type of motion? Rotary motion, translation, rotation, translation, and how can we combine the motion, and we combined also the member, that means the links, and links has to be connected to each other, and then we have to consider which type of joint we need, and which degree of freedom we need, and so on. all those things has to be considered. Okay. So you see here some example, and we have here rotating full pin revolute joint here. You see revolute joint. Form closed. You see form closed. Formally closed. Cannot be say the disassembled by itself. So then we have here translating full slider prismatic joint, for example. So the motion is in X direction. Those are, I mean, the pairs. Huh? We already discussed it. If we have a two link and one joint, we say it's a pair. So consists of two link and one joint. This is a pair. So this is a prismatic. This is a revolute joint connection and consists of two members, one pairs, and this pair has a slider joint. That means the prismatic joints, and this is form closed also, huh? Form closed. And here we have, so of course we should say this is the reference. This we fixed, and this can turn. Huh? So this one we fixed. So this we can turn, and also here we fixed this one. We fixed this part. We fixed, and the slider can move left and right in X direction. So 1 degree of freedom. So here also this we can fix, and also it can move in that direction or in that direction. That means the rotary motion. And first order pair, 1 degree of freedom. And here we have different connections. We have two members connected to each other using one joint, pin joint. And we have here 3 degree of freedom. Because if we fix one of them, let's say this, we fix this one. So this one. And this can move and this can move. So this has 3 degree of freedom, where this one has 1 degree of freedom. So you should not forget, we have such an example. If you have such a connection somewhere, that means 3 members connected. So then it has 2 degree of freedom. So 2 degree of freedom. So in this example, roll slider. So we have also 2 degree of freedom. One is the translation, the other one is the rotation. This is the fixed one. We fix this. And here we have also pin slot connections, 2 degree of freedom. So we have one here revolute joint and one here this slider. That means prismatic joint. And here in this example, we have 2 degree of freedom, 1 or 2 degree of freedom. If we have rotation and translation, then we say 2 degree of freedom. If we have only rotation, then 1 degree of freedom. So if a planar, I mean, if it's only rotate, then 1 degree of freedom. And at the same time, rotation and translation, then 2 degree of freedom. Okay, so links and pairs. So we said this is the binary link, this is ternary link, this is quaternary link, and this is grounded half joint. Grounded. This is, this sign means grounded. So this one is grounded. And here, moving rotating joint, pin joint, moving rotating joint. And this means grounded rotating joint like this, huh? Like we already discussed. So it says only one joint, one degree of freedom, and this is rotation. So grounded rotating joint. This is moving translating joint. Translating, like a hydraulic cylinder or pneumatic, or hydraulic linear actuator or pneumatic linear actuator. And this is grounded translating joint. Grounded half joint, grounded translating joint. And this is moving half joint, because the two parts are moving on each other. So we have here an example. So let's see in these examples what we are talking about. So let's give the name. What is the name of that? Grounded translating joint, isn't it? So grounded okay. Grounded translating motion, because it is the motion, it is a linear motion translating left and right. Okay, what is this one? And this is moving translating joint. Moving, which moves, huh? Moving translating joint. Let's say translating joint, huh? That's abbreviated. Okay. And here this is grounded rotating joint. Grounded rotating joint. That's so it's abbreviated. Okay, this is also grounded rotating joint. Okay, this is ternary link. Ternary link. This is also ternary link, has three connections. This is binary. This is binary link. And you should learn all these definitions, all these names. And this is here what we call moving half joint here. Moving here and this part. So moving half joint and so on. Okay, in this example we already have discussed all of them. So, okay, let's continue. So you see we have here a mechanism and kinematic diagram. This is a mechanism. So weight training mechanism in sport, how you can see that. And there's a mechanism seems like this. So we have here on joint, rotary joint, here rotary joint. So grounded rotating joint, so grounded rotating, grounded rotating, grounded rotating. And here we have what we said, we have moving half joint here, moving half joint and so on. As you see, we use the mechanism, let's say, in many applications. And this is ternary link, and this is binary link, and so on. So another important definition is open and closed mechanism chain. So we are going to talk about the chain mechanism and chain. But this is a mechanism. So what is mechanism? What is chain? What is kinematic kinematic model? So this is an open chain because this is not closed, and this is a closed chain. This is closed mechanism chain. This is open, actually not chain, but it is open mechanism. Open mechanism. This is closed. So open means like a roboter. Huh? So a robot is actually, if we talk about a robot like this one, and so on, has to rotate. Huh? So and has such a joint, let's say, and which has also such a rotary joint. So it is an open kinematic chain. Because this part can rotate like this, and this also can rotate like this, and this also can rotate like this. Open chain. But this is not an open one. This is closed. Because we already learned that this part is the grounded joint, this grounded joint here. This is also grounded joint, but not here. Huh? So this is also grounded joint, and it is closed, as you see here. So member one, we don't draw it. Actually, there is a member one here, like this, but we don't want to draw it. This member is fixed to the ground. And therefore, we said the grounded joint. And we call it 1. This is 1 here, 1. And this is 2, the numbering. And this is 3, and this is 4. Okay. Closed mechanism, open mechanism. But chain, if you say chain, I will explain you. Chain is something more. So, and chain means actually we have if you have a 4-bar mechanism like this, 4-bar system like this, and if we don't fix any one of them, I mean, this is 1, this is 2, and this is 3, and this is 4. If we don't fix any of them, this is a chain. If we fix one of them, this is a mechanism. In this case, if we fix the first one, and we achieve a mechanism, we can fix the member 2 or member 3 or member 5. You will see later. So we will achieve different type of mechanism. I will be back in a second. Okay. So the kinematic chain or chain means a chain no of the parts are fixed. If we fix one of them, then we achieve a mechanism. Okay, let's continue. Here, of course, we will discuss the planar motion. Is there any question? So when I say please, I am using the full screen, so I cannot see what you write, your message. Huh? But if you talk, I can hear you. So please, if you have any question, please talk, okay? So fix means, let's come to that. Fix means we have, let's say, the 4-bar mechanism. Let's grab it once more. So 4-bar mechanism consists of 4 bar like this. So, and let's say this is the member 1, member 2, member 3, and member 4. Okay. That's the reason why we say 4-bar mechanism. 4 bar consists of 4 bar. Huh? So, and the bars are connected via the joints. And joints we discussed could be different. Could be a pin joint or revolute joint like this, or could be slider like this, or prismatic joint like this. Oh, so this means this sign means grounded, doesn't move, static. Huh? The moving part is this part. Huh? This part moves, slide, and this is slider. And this part doesn't move. It is therefore, I said, it is fixed. There is no motion. So if we fix the part 1 here, that means grounded. So like this, or in some cases, instead of that, we use this type of indication. So this is also another possibility to use. Okay, huh? So that means the member 1 is grounded, but we don't drive it like this. We don't drive it like this. There is no need. There is no need. That's the reason. In some literature, maybe you can see that they drive, but there is no need for that. So fixed means grounded. And one of them is the driver, like this. And this is follower, and this is the coupler, this one. This is the coupler. Couple this part and this part is link, and these 2 links. Okay? So, any question? Good.
Thank you, teacher.
Okay, you are welcome. So here, let's talk about the planar motion. So planar motion, actually, we discuss also in the dynamic. planar motion, and we will use what we learned in dynamic, especially in the part of the kinematic. So two unconnected links. You see this first one and the second one. If those are not connected and they move on the plane, so that it undergoes the planar motion. So it could be the moves in x direction, y direction, or rotation, and so on. There's a plane motion. So we can describe the plane motion like this. Occurs on a plane. Oh, no. I change it. So, on a plane. So on a plane means that, so there's a plane motion. Okay. This is our plane, let's say. I said we will use the geometry, and our lesson involves very much into the geometry. So if we have a part on this plane, let's say like this, there is a such a, maybe I have to redraw it, didn't. Okay, so use it once more. Okay, so on the plane, so this part, this object, we want that it makes planar motion. So what does it mean? In plane, it can move in x direction, like this, x. It can move in y direction, and it cannot move in x direction. It's not possible, So, because the object should be keep the contact to the plane. So therefore, two motion in x direction, in y direction, but it can turn around the z axis. It can turn like this, rotary motion on the plane, turning. That means 1 degree of freedom, another 1 degree of freedom, this rotation, so that 3 degree of freedom. 3 degree of freedom. But if we have two parts not connected like this, two unconnected link like this, each of them can fulfill 3 degree, it can have 3 degree of freedom. So in total, they have 6 degree of freedom. Rotation, translation, and here also translation, and rotation. And if we connect them by a, let's say, the pin joint or revolute joint, what will happen? So they can rotate, of course. They can move x and y direction, but they have not each one can move in x and y direction. Both of them has to move in x and y direction. So therefore, the degree of freedom reduced to the 4. So you can imagine, If they are separated, they have altogether 6 degree of freedom. But if we join them using a pin joint or the revolute joint, so the degree of freedom reduced to the 4. So the connected by a roll slide half joint, if we have applied such a roll slide half joint, then we reduce the degree of freedom, 6 degree of freedom, to the 5. Okay, so now our interest is how can we calculate degree of freedom of a mechanism. So if we have a mechanism like this, let's draw a mechanism. I'm drawing a mechanism. Let's say we have a 4-bar mechanism or 4-bar chain. Let's say this is a chain, 4-bar chain. So, and this is our 4-bar chain. So I'm going to fix the first one. This is the first. This is 2 and 3 and 4. So I'm going to fix the first one first. So that means I create such a mechanism like from that. This is a chain, and I'm creating a mechanism like this. So here. Okay, I fix it, So I ground it. In machine, this is the body of the machine, housing of the machine. Doesn't move. There is no motion regarding the part 1. Part 2 moves, okay, let's say clockwise. And part 4, this is part 1. We say part 1 and part 1 also fixed. And this is part 2 and part 3 and link 4. Okay, it maybe undergoes this motion. So what is the degree of freedom of this mechanism? I mean, not all the members, but if you connect the members, there's many links together. So then we achieve a mechanism. So we are interested to know the degree of freedom, total mechanism. So therefore, there is a formula here. So degree of freedom is equal, F is equal for the mechanism is equal 3 times N minus 1 minus 2 joint prismatic or primary, let's say, minus G higher pair. So primary and higher. So is the definitions. So that means primary has 1 degree of freedom, higher has 2 degree of freedom. So you see here number of higher order joints, and this is the number of primary joints. So let's check this mechanism here. So the N is the number of the link. So F is equal. So how many links we have? N is equal what? How much? How many? 4, isn't it? N is number of links. 1 in the grounded is grounded. 1, 2, 3, 4. Okay. And let's come primary joint. How many primary joints we have? Joint primary, that means 1 degree of freedom. We have 1 here, 1, 2, 3, and 4 joints.
Yeah.
4, right. Let's write here also 4. So, do we have a higher order joint? Not, we don't have. We have only joints with 1 degree of freedom. It's a prismatic, it is revolute joint. So then let's apply the formula. So F is equal. So F is equal 3 also 4 minus 1 and minus 2 times 2 times 4,
4.
and minus 0.
Yeah.
There is no higher joint. So then this is here is equal with 3. It makes 12. 9, sorry. 3 times 3, 9. Minus 8. So is equal 1. So that means the mechanism has 1 degree of freedom. What does it mean? So 1 degree of freedom. That means if we apply any motion from the part 2 or 4 or 3, it starts to move. All the members connected starts to move. 1 degree of freedom. That means we have to apply one motion, one single motion from any of these 3 links, so the mechanism start to move. Like this, yeah? We apply the, let's say, the rotation here. If we apply the rotation here, you can see the 3 also moves, and 4, all 3 and 4 mechanism shape members are in motion then, start to move. In connected situation, of course, in connected way. So what did we learn? We learned actually, so how can we calculate the degree of freedom of the mechanism using the joints, members, and links, and so on. So in our next lessons, we will continue. We will check some mechanism regarding the degree of freedom, and we will make some, have some examples to calculate the degree of freedom of the mechanism and so on. Okay?
Okay, sir, I have a question. Will you share these documents with us, or do we
Yes,
need
I will
to buy?
share. Yes,
Yeah.
I will share. I have also a PDF book. I find it in the internet, and it is good for you. And I will also use this book, and I will share also this book. Okay?
Thank you very much.
You are welcome. Okay, bye-bye.
See you. Bye-bye.
See you.
Take care, sir. Bye.